So from data to visualization, what are the sort of the typical steps involved in making a data visualization? How do you get from data to having created visuals? And I think that a sort of a nice introduction to this question is this is a visualization made by a designer called Rachel Dot. It is just sort of a fun, playful visualization she made of what is the cat population across the UK. She made this map. I'm not sure it's an especially profound visualization. I think maybe it just maps to population density. But as I said, it's a bit of fun. And what's interesting here is that she actually created this diagram where she has shown what her process was making the map. And you'll see that she starts off in the left-hand side with idea, and then she has split her steps into get data, prepare data, make map, and then make map better, which is more sort of dealing with the visuals. And so I think that what's kind of interesting and important to notice here is that there is a whole lot going on in the get data, prep data, make map side, which is all about data preparation, data cleaning, and that there's actually an awful lot of that compared to the amount of time or steps working with the visuals, getting the visuals of the map really good. And another thing to notice here is that in some cases she's almost sort of going around in circles, where she's got the cat data that she wanted to work with, but then she's realized that she's got the wrong data set. It's too granular, so she needs to go back and switch out for some different data. She, is producing the map and realizes that she doesn't have the labels for the place names, so she has to go back and get that and process that data. So there is, something of a bit of a circular process going on as well. But yeah, so as you can see, there's a lot. You can be spending a lot of time doing data processing, data preparation work when you're making a visualization. It's not purely working on the visuals. There's a lot sort of under the iceberg as you're on the way to making visuals. And these are just some prototypes that she made along the way of this map of cats across the UK. So I think that we can, I would roughly characterize the visualization pipeline or workflow as something like this. So we'd start on the left with our data set and the various different kinds of processing that we'll want to do with our data set. We might need to clean the data, we might need to filter the data, we might need to bring in other data sets. We might not have everything we need in the one data set we started with. We might need to do some analysis. We may need to create some new facets in the data, some new variables in the data. We may need to reshape our data. And then with having prepared our data, we'll be able to create a visual. And again, you see I've got these sort of swooping arrows underneath the pipeline, that it's not necessarily all sort of step 1, 2, 3 made visuals. You may realize that you need to go back and actually do some more data preparation that you hadn't realized when you started. A really, I think, important point when you're creating a data visualization is that what you can make is going to be determined by the content and the shape of the data that you have, or the data that you can get. This is a really useful lesson to learn, that even if you have a sort of a wonderful idea of some chart or some map that you want to make with a cultural heritage data set that you have that you think would be really amazing, that unfortunately, if the data that you're working with doesn't have quite the things that you'll need to make that map, it's going to be impossible, or it's going to be unfeasible for you to make exactly what you wanted. So and I've certainly been burnt by this in the past. When I first started my PhD, I was working with a data set from the British Library, a data set of digitized playbills from theatres in the 19th century. So it's sort of posters advertising theatrical productions, really sort of amazing typography, font design, on these posters with the play name, the theatre, the different actors, really sort of amazing images. And I thought this would be really wonderful if I could pull out the names of the plays on each of these posters, and then I could find all of the different posters for every time that Hamlet, for example, has been put on across this large data set of posters. And we could see, all of the different theatres, all of the different actors, and we could trace that across time. But unfortunately, pulling out the text from these poster images turned out to be very, very difficult. We tried using OCR, optical character recognition software, to convert the text in the images to computer readable text data. And unfortunately, because it was 19th century typefaces, really very difficult for the software to read. It really didn't do a very good job. And it meant that it was just going to be impossible to find every example of Hamlet across this data set. So I had to really change my expectations, change what was going to be a sensible, feasible approach with visualizing this data. So I say it's always very useful to really be led by what is in my data, what is the shape of my data, and thinking about what can I do with this, rather than having sort of a very wild imagination of the sort of wonderful thing that I'd like to be able to make. To really think carefully, is the data actually, has it got the information that I'm going to need to be able to make that? When we talk about collections as data, and as a reminder, so I'm using this term cultural heritage data to refer to data that represents holdings of cultural heritage institutions. So this could be metadata and digital reproductions of, for example, artworks, photographs, books, other kinds of publications, archival material, a really sort of really broad, wide range of different kinds of items that we find in cultural heritage institutions. And across those, we can think about, there are different kinds of data sets. So there's a lot of tabular data. I think we see a lot of sort of spreadsheets, tabular data, which might be the records in our database. We might also find network data. So this might be links between people, links between organizations. We might find trees or hierarchical data. So for example, archive series are hierarchies. That's an important structure in our data. Another type might be spatial data. So for example, data that has coordinates, that has places, that has latitudes and longitudes, where it might make sense to think about mapping that. We might have text data. So this might be raw text, but it also might be structured text like Alto in digitized newspapers, or we might have images or sound or even video. So there are a whole range of different data set types. We can also think about what are the different types for the variables in our data. And this is actually quite important when we think about how we want to visualize our data and what's going to be the best approach for visualizing our data. Because the variables, there are different variable types in our data. So for example, we might have categories. So an example of this might be different authors of books in our collection. But we also might have different kinds of ordered data. So, for example, the chapters in a book, chapter 1, 2, 3. There's an inherent order to those data points. We might have temporal data. There's a lot of temporal data in cultural heritage collections. We might have dates, we might have years, we might have lifespans. We might find quantitative data, counts, number of records, number of pages, all kinds of summary quantitative data. And there are other kinds as well, sequential, diverging, which might be a measure of change, or even cyclic. So when there is a sort of a cycle. So a good example of this would be a calendar of dates. Every year we go back to January the 1st. And so this might be important for thinking about what would be a sensible or a good visual way to represent my collection data. So talking about the sort of kinds of steps in data processing that we might need to do when we're creating a visualization, I'm going to use this example, Press Picker, as a case study to step through those different processes and give examples of what exactly I'm talking about. So Press Picker is a tool that I developed with colleagues at the British Library. It's a visualization tool to see the holdings of different newspaper titles in the British Library. And the reason that we developed Press Picker was to help us make decisions about which newspaper titles we wanted to digitize. We had some budget to digitize some newspapers. We knew that we wanted to, if we were going to digitize a newspaper title, we wanted to digitize every issue. But the format that those newspapers were held in the library, whether they were hard copy, so hardbound volumes, or whether they were microfilms, so on a kind of film reel, was really important for planning the digitization, because the microfilms are much quicker and much cheaper to digitize. So we wanted to be able to see which of the titles in the library have mostly been microfilms, so we'll be able to digitize off microfilms. But there was also an important consideration that some of the early microfilms at the library were done on material called acetate, which has since degraded, so we actually can't digitize off those ones. We needed a warning in the visualization to let us know that some of the microfilms might be acetate. And a further complication, you can better see the interface design here. A further complication with this data is that newspaper titles sometimes change their name through time. And in the British Library, if a newspaper changes its name, that is treated as a completely new record in the library's data. But we wanted to be able to bring together the titles which were a result of name changes, because we, in some sense, these items are sort of the same title going forward. So in this visualization design, you can see here, for each title, we had little line graphs which showed the holdings in the library. The red line is the microfilm holdings, the black dotted line are the hard copy holdings. And then at the left, we've got the title names, and we've also got little numbers which are showing us the summary information for each title. The red number is the total number of microfilms, the black is the total number of hard copies, and then we have a little red warning icon if any of the microfilms are done on acetate, that material that we can't digitize off. And then this branching design at the left, which is bringing together titles which are connected by a name change. And so we created this visualization design to be able to overview the data and choose which were going to be the best candidates for digitization. So I'm going to step through the how we made this, what were the steps that we had to do to create this visualization. It is quite a complex example. It's obviously it's a custom design. So I think I wouldn't be sort of worried or scared when we go through a lot of steps here. You know, if you were creating a more simple graphic, it certainly wouldn't be this level of data preparation, but I think it's still a really useful example because it covers basically all of the different kinds of steps that you might have to do. And this is just a, you can see the key for how to read this. So the line graph is the number of records per year, and then the totals, the numbers at the left. So starting off with data processing, what are the kinds of steps we're going to want to do with data processing? So for example, with starting with a master title level data set of newspaper titles held in the British Library. So we needed to clean the data. This is very, very typical with cultural heritage data. Data is often messy. It's not a big deal. It's sort of that's very normal, but we need to clean our data in order to make best use of it. So we want to remove any duplicate records. We want to make sure that if we've got multiple values all in the same field, we need to split those into individual cells. We want to make sure that if there are values which actually mean the same thing. So I have in my third bullet point example here, Inverness, Isle of Skye, and then the same but with brackets. We obviously, as a human, know that that's referring to the same thing. So we want to make sure that we reconcile values that actually mean the same thing. We want to make sure that our dates are machine readable. There are various different tools that you might use for doing this kind of work. You can do data cleaning in Excel. OpenRefine is a really popular tool used at the British Library, which is sort of like Excel, but even more powerful. And there's a very good programming historian tutorial for stepping through how to use OpenRefine. If you prefer working in a programming language, then you might want to use pandas with the Python programming language. And R also has a lot of very good tools for doing this kind of work. We might need to filter our data. So in the example of Press Picker, we obviously didn't want to pick any titles which had already been digitized. So we need to filter out any titles that are already digitized. We were interested only in places, a set of counties. So we needed to make sure we'd filtered those. And we also had a date range that we were interested in. So we needed to filter out anything outside of that date range. We might need to join to other data sets. We started with this title level, sort of master high level data set. But in the visualization, it shows the number of microfilm holdings per year and also the number of hard copy holdings per year. Those had to come from separate spreadsheets. We had to request those and then join them to our main data set. So you might need to join in other data. We also might need to do some computational analysis. So for example, in Press Picker, we've got summary information on the far left, these counts of the number of microfilms or the number of hard copies. So we need to create those summary numbers. In this example, also, we did this bringing together of the data where there have been name changes. So we might need to link records together that weren't previously linked in the data. And there's also a whole lot of things you can do to enrich your metadata, which might be useful for creating a visualization. So for example, with the titles in the British Library, my colleague did some work to add a county new column in the data set, which meant that we could then map the data by county. We could see how many newspaper titles per county there were in the British Library. So you might want to do something like that. You might want to, it's actually OpenRefine is a really excellent tool for enriching your metadata. So for example, doing named entity recognition where you're extracting names of people or places from your data, which can be helpful for processing and visualizing. You might need to restructure your data, or to, essentially what I mean by this is to kind of change the shape of the data. So certain data visualization types expect and require your data in a particular form. And so sort of an example of this is in the press picker tool, we've got these line graphs for every title. We've got these lines which show the number of items, microfilms or hard copies per year. And so the problem is that the data that we started with here was record by record data, and that's very, very common in cultural heritage data. You'll get, a new row for every record, where for these line graphs, the horizontal axis is years, and then the vertical axis is count of records per year. So it's not record by record. We actually need a summary count for every given year. So what I need to do is I need to transform my record by record data. So the shape of the data on the top left of the slide, and I need to transform that into a summary time series data, so that I've got, for each year, I've got the count, the total count of items for each title. So you need to do this change of shape in order to create the line graph like this. And this is sort of a really, really common step that you'll need to do if even creating very simple graphs or charts. So as I said, record by record data is really, really common in cultural heritage data. And so just to, for example, create a bar chart like this, where we're looking at the number of records per country of publication, you need to take your record by record data and to create a summary table. So in this example, getting the total number of records for each country of publication. And there are various different tools you can use to do this. You can do it in pivot tables in Excel. You can do it in OpenRefine. You can do it using programming languages. And we're going to talk about tools later on in the presentation, but this is a sort of a fundamental step that you need to be able to do. And if you're creating more complex graphics, so for example, this is a network diagram. This is a network of the characters in Hamlet from the Literary Lab at Stanford. If you're creating a network diagram, then your visualization will expect your data in a particular form. So this is the sort of standard form for creating networks, is you have two tables of your nodes, which are the kind of the points in the middle, the names in this case, and then a separate table for links, which is the data about the connections. So it expects that you have transformed your data into this form in order to visualize it this way. Similarly, if you're working with hierarchical data, so this is a tree diagram at the top right, which shows the different subjects at university, and so it shows the sort of hierarchy. So Middle Ages is part of history, which is part of the humanities. This is a hierarchy. And again, if you're creating one of these visualizations of hierarchical data, your visualization tool or software will likely expect your data to be in this form at the left of the slide, where you have the different hierarchy levels in the different columns. So it's very, very common that you'll need to change the shape of your data so that it is the right form for your visualization. And so we had to do this again with this bringing together of the titles that change their name. We created this branching structure at the left of the visualization. And so we had to change our record by record data into creating these nested groups. This is not something that we did in Excel. We did this using the Python programming language. But this is just another example of it making sense to change the shape of the data in order to create the visual that you want. So this is, yeah, just a reminder again of this data visualization pipeline of starting with doing data processing, changing the shape of our data to support the kind of visuals we want to make, and then creating our visuals at the end. Now, so we're going to talk now about visual design, which is, I think, something that is really, really important, but often overlooked in data visualization training. Because sadly, it's not necessarily the case that you've got data, you've created visuals, and then immediately it's insight. Unfortunately, it doesn't always work like that, and we can see here, this is a sort of classic example of, we'd call this a hairball network diagram, where this is so overwhelming and complicated that there's really, we can't get any information out of this. We don't know what's going on. It's just all too much. Similarly, this is sort of a joke example that a visualization professional posted on Twitter, saying it's so obvious I'm a professional, that this is just completely overwhelming and it's not possible at all to see what's going on. So when we're thinking about the visual design of our visualization, there are several different aspects of the visual design that we might want to consider. These include graphical integrity, the legibility of our graphic, clarity of purpose, and also the tone, associations, and context in our design. And I'm going to step through what I mean by these different things. And I'm taking these ideas from somebody called Edward Tufte, and Edward Tufte's books. So Edward Tufte he's an American statistician, and he is really noted for his writings on information design, and is a pioneer in the field of data visualization. And he's best known really for a series of books that he wrote about visualization design. These are two of the sort of most well-known ones: The Visual Display of Quantitative Information and Envisioning Information. And he had such strong feelings about design that when he found a publisher who was interested in publishing these books that he wanted to write, but he felt so strongly about how he wanted them to be designed, that he explained to the publisher that he wanted to sort of do the design for the books himself, and the publisher wasn't very happy at the idea of the author designing the book as well. So Edward Tufte actually he decided that he would self-publish these, and he sort of took out a second mortgage on his house and hired his own book designer. And the books themselves are beautiful, and really are sort of exemplifying the principles that Edward Tufte is recommending. And I really do recommend having a look at these if you're interested in the design of data visualization. They're really, really interesting, really inspiring, lots of great examples. They're a really good thing. So one of the principles that Edward Tufte talks about in these books is graphical integrity. And what he means by this is the representation of numbers as physically measured on the surface of the graphic itself should be directly proportional to the numerical quantities represented. Clear, detailed, and thorough labeling should be used to defeat graphical distortion and ambiguity. Write out explanations of the data on the graphic itself, label important events in the data. Graphics must not quote data out of context. So it's all about being clear, not distorting, not being ambiguous, making sure that our visual elements accurately represent our data. And so a good example of that is if you're using 3D graphics, that can distort the size of elements in our charts. So this is a kind of pie chart that was on the American news when before the previous election, when there were various Democratic candidates being selected to run for president. And so we can see, I've actually blanked out the percentages for Sanders, Biden, and Buttigieg. So have a look. Which of these pies do you think is the largest? Who has the largest share of votes? I mean, to me, it looks like it's Buttigieg. But if I remove the percentages, it's not Buttigieg. It's simply that his pie in this 3D chart is sort of closest to us. And actually, Biden and Sanders have the bigger share, even though theirs don't look equally sized at all either. So you have to be very, very careful if you're using 3D. It's generally a good sort of principle not to use 3D really at all, unless there is some really good reason for needing it, because it just so quickly distorts the shape of everything. This is another example. If you are creating a bar chart, you have to be really careful that you shouldn't cut off your y-axis, because in a bar chart, it's the height of the bars which you've encoded your quantities to. And if you cut off the bottom of your vertical axis, then you're distorting the height of the bars. So we can see here that if in this example graphic of the proportion of disabled people aged 16 to 64 who are owner occupiers by country in the UK, that if we make sure that the vertical axis does in fact go down to 0, that it paints a very different picture, and actually the disparities between the countries actually looks a lot smaller. So it does make a difference what we take away from seeing these charts. Another thing to consider with kind of distortion and how we present our graphics is thinking about what is the kind of natural way that people will read your chart. So this is an example, a chart which shows gun deaths in Florida. And so this chart is showing the number of murders committed using firearms. And we can see that it's been annotated. So 2005, Florida enacted its Stand Your Ground law. And just looking at this, it seems, okay, after they've introduced this law, then the numbers of murders have dropped. So that the law must have been a good thing. It must have been a success. But what actually is going on, if you check the horizontal axis, is the horizontal axis has actually been flipped, and the axis actually goes down. It doesn't go up. So if we were to flip the chart so that the axis now goes up, we can see that actually the chart is telling us the complete reverse, that following the Stand Your Ground law, the number of murders committed with firearms has actually jumped. So we have to think very carefully, what is the kind of natural way that people will sort of read your chart. And if you're, for example, flipping the axes, people may, as a consequence, misread what they're seeing. This is a recent COVID example. This is from the Georgia State Health Department. And so this chart it's showing the number of cases over time for particular counties. And this sort of looks like things are going well. The number of cases are dropping over time. But if you have a look again at the horizontal axis, what you'll notice is they've actually reordered the time points so that it's not a straight sequence through time. They've reordered them so that it looks that the cases are all going down. So again, this is this is thinking about what is the kind of natural way that people will read your chart, make sure that you're not distorting or misleading. A very good and recent book written by Alberto Cairo is How Charts Lie, which is a really interesting view into all the different ways that charts can distort or sort of misrepresent, or really just as sort of charts as a sort of rhetorical device for arguing in a certain direction, which is, yes, which I recommend, is really interesting. Two resources which I think are really useful and actually really good, from the Government Statistical Service and from the Office of National Statistics. They've both published sort of guidelines for creating charts and tables and best practice. And I actually think these are really great. They're concise, to the point, but they're a very practical how-to for spotting particular pitfalls and making sure that you avoid them when you're designing graphs and charts. It's also, I think, really useful to always remember that data visualization, just like any other form of communication, the written word, the spoken word, can be used rhetorically, and can be used, deliberately to persuade in particular directions. And maps are something that have been really sort of studied to explore exactly how this works, and really are a sort of a key example of tools of persuasion and power. I like this example with Argentina in the center of the world. Anyone can be in the center of the world. It depends how you place, how you draw your map. And this is a quote from a recent exhibition all about the ways that maps can be used persuasively, from the Leventhal Center. And they say, maps, truth, and belief have a complicated relationship with one another. Every map is a representation of reality, and every representation, no matter how accurate and honest, involves simplification, symbolization, and selective attention. Even when a map isn't actively trying to deceive its readers, it still must reduce the complexity of the real world, emphasizing some features and hiding others, compressing the round globe onto a flat sheet of paper and converting places, people, and statistics into symbols, lines, and colors is a process inherently fraught with distortion. And I think this is a really important point. I think that we're probably all sitting here thinking, well, I'm not going to create a graph that, would deliberately mislead people, that would deliberately distort information. But because creating visualizations is a process of simplifying, of emphasizing certain pieces of information, it is quite easy to accidentally distort things. So it really is good to be vigilant and be thinking about the ways that you're presenting information. And a very good example of maps as rhetoric is the maps from the American presidential election, not the most recent one, but the one previously, where Donald Trump was the winner. And this is, yes, Donald Trump's favorite map that he liked to put on Twitter of the way that the different counties in the US voted. And you see that they hung the map up in the West Wing in the White House. But actually, that's not the only way we can present that data. Donald Trump really likes to see which way did all of the counties vote, but land doesn't vote, people vote. So we could present the same data in a different form. And this animation is showing that, in fact, we can show what were the number of voters in each county. And we can see that the Democrats, the counties where the Democrats won are often counties where there are much larger populations. And this creates a very different kind of message of how the election turned out. So if you just want to take 10 minutes looking through I've included a whole set of maps in this document. Have a look at the different maps, and for each map, have a think about what story does this map tell? How does the success or failure of the two political parties appear in the map? Because I think you'll find that it can look quite different. Different people definitely prefer different maps, and I think that really says a lot about design. This isn't a science. There's often not a sort of correct answer of what is the sort of right way to visualize information. Different people will prefer different things, and I hope this exercise has been interesting, because it's not that any of these maps are wrong. It's really all about the choices in how you visualize your data. And those choices can have a huge impact on the sort of main messages, main takeaway of the graphic that you create. So really, there's a lot of power in the person who is making the graphic, and a lot of agency in the message of the thing that you create in the end. And this is an exhibition, I think from last year, digital exhibition by the Leventhal Map and Education Centre at the Boston Public Library, which is all about maps and data, distortion and deception. So if you're interested in this topic, I really recommend having a look at bending lines, because it's all about this topic. So moving on to legibility of graphics. So when we're talking about legibility of graphics, I think we can think about, there are sort of two different sides to this. The first is all about visual mappings. And what I mean by that is that when we're creating a graph or a chart or a visualization, the sort of whole activity of what we're doing is going from, we have some data, and then we want to use different kinds of visual variables to communicate our data. So we could say translate our variables in our data to different kind of visual qualities. And so we can think about this as there are different kind of marks that we might use, points, lines, areas, and then channels are the different visual qualities that we might use to communicate the different categories or the different values in our data. So we might use position in a scatter plot. We use position of points to encode our data. We might use color. We might use different shapes. We might use different sizes. In a bar chart, it's you're encoding values with different sizes. So these are the sort of the different visual variables that we use when we're translating from data to visuals. And so part of making a really legible data visualization is making good choices in what are the visual variables that we're choosing. So this is a great example from the New York Times, where they were mapping Hong Kong election results in 2019. And so what they've done in this map is that they have colored the areas which elected representatives that were pro-democracy yellow, areas that elected representatives that were pro-Beijing blue, but they've got a second aspect of the data which they're communicating, which are the districts that flipped. And what they've done with that is they've used hatching, and this is really nice because it means that we're not overlaying our pro-democracy, pro-Beijing color scale. Hatching is really nice because we can have that, we can layer that over the top, and it doesn't confuse the yellow-blue binary that we've already used in our chart. So this is a really sort of clear, simple way of having those two sides of the data being communicated at once. Something to think about with different visual encodings, or these sort of different visual variables, is that some are better than others. And I mean better only in the sense of because of the way that the human visual system works, we just are better at accurately judging the difference in value for certain kinds of visual variables. So essentially, we are much better at judging the differences in position or in length than we are in judging the differences between angles or areas or colors, just because of how the human visual system works. So a good example of this is that if we look at this pie chart, which of these slices of the pie is biggest, which is smallest? Very, very difficult to judge because they all look pretty similar to me. They're all pretty close. But if we were to visualize the same data in a bar chart, it's suddenly completely obvious what's going on, much, much easier to judge. And that is just, this is how eyes work. So lengths and distances is just much, much easier to see than angles. We can use sort of different visual variables, these different encodings. We can layer these in to really fit a lot of information into a graphic if we're using different variables for different elements of our data. So this is an example. It's another election graphic. You see there's a lot of great election graphic examples. This is from the UK general election in 2019. And in this map, Roger Beecham, who created it, he's really fit a lot of different aspects of the election data onto this map all at once. So he's used a line for every constituency. He's used the color of the line to communicate which was the winning party. So was it Conservative, Labour or other? He's used the thickness of the line to communicate whether the constituency flipped or not from the last election. So if it's a thick line, then it flipped. And he's used the angle of the line to communicate what was the swing in vote share from the last election. And so we can see that he is communicating, it's a really sort of data dense graphic that he's managed to fit a lot because he's using this whole array of different visual variables that can all work together sort of in complement. This is an unusual example, a visualization called Poor But Healthy. And what this is, it's a map of London, and it's showing the prevalence of diabetes in London, and it's comparing that with the diversity of nutrients that people get from their groceries. And so it's also adding into that what is the income in particular areas of London. So the whole point of the map is to look at income and nutrient diversity from your groceries and to see how does that map to incidences of diabetes. But it's a really unusual kind of experimental way that they visualize the data. So I think it's quite an interesting example, sort of a very unusual, perhaps you might say artistic way to present the data. It's certainly eye-catching, but I think I've certainly heard from some people that they find this very difficult to read, and so there are problems with legibility if you are creating a sort of a visual design that is very unfamiliar. Then it can create problems for people reading your graphic. So the second side of legibility of graphics we might think of as tidying up. And what I mean by tidying up is there is this concept that Edward Tufte talks about in his books called the data-ink ratio. So he says data graphics should draw the viewer's attention to the sense and substance of the data, not to something else. Above else, show the data. And so the data-ink ratio is this sort of imagined measure of what is the ink that's used to show your data as a proportion of the total ink used to print the graphic. And so Edward Tufte suggests or argues that when you're designing data graphics, you should always be aiming to maximize the data ink ratio. So to maximize that the imagined ink in your graphic is mostly being used to show the data and not other things. So maximize the data ink ratio within reason, and erase non-data ink, again, within reason. So, and what's quite nice is in the books, he looks at some examples from William Playfair, you might remember from last week, who invented a whole host of sorts of classic chart types that we use today, for example, including the line graph this is sort of the late 1700s. And Tufte says that we can see here, it's Playfair sort of getting the hang of maximizing the data ink ratio. So on the left, he's got these very heavy grid lines, and realizes, we don't need the grid lines. The grid lines are not the most important thing in the graphic here. The most important thing is the shape of the lines. And so in a later similar line graph, we see that the grid lines are much more faded out, and we're drawing attention to what's more important in the graphic. This is a sort of a similar example of, this is a type of chart that is very popular with people who are managing railways, and you use these charts to show the location where trains are starting, the stops they go on, and the sort of the angle of the line tells you how fast your train is going. So this is a great way of sort of overviewing railway timetables. And again, if we compare these two, we don't need these heavy grid lines. It makes the whole thing very dark and draws away from what's important, which is the lines of the trains in this graphic. So this is another example again of tidying up. This is a sort of a very busy, heavy graphic. And we can redesign this because we don't need that gray background. That's not needed. The most important thing here are the shape of the lines. So we don't need the sort of big data points that are obscuring the shape of the lines. It's much more helpful if we've labeled the different lines with what they refer to. It's quite difficult to distinguish between these. Some are quite similar colors. We don't need this big graphic. That's sort of not helping us at all. We can make the grid lines, a lot lighter, and we can label some important context to the data. So this is the process of tidying up, and this is something that really just is sort of a question of practice, and then you get very good at this, and removing things that are not needed in your graphic to really highlight, what are the important things that I want to show, what are the important aspects of this visual. And this is just much cleaner, tidier, easier to consume. And so if we return to Press Picker, the newspaper titles visualization that I was talking through when we were talking about data processing, when we were developing this visualization, a sort of earlier prototype looked like this. It's not a disaster. We can still kind of see what's going on, but we have much sort of heavier baselines for all of the graphs. And that's not the most important thing about this data visualization. It's more important that we're able to really read the titles of the newspapers, that we're able to see the shapes of the holdings of each newspaper. So although it's not sort of the end of the world, our earlier design, I think it is an improvement that we've just lightened the baselines here so that we're really drawing attention to what's more important in this graphic, to really draw the eye to what's more important. And if you remember, again, this visualization, this information graphic from last week, this is the Charles Minute figurative map of losses of men in the Russian campaign of 1812, which has been described by some as the best information graphic ever created. This is very much he's removed everything that is not necessary. There's very little kind of base map to this because it's not necessary for this piece of communication. He's really narrowed down to what are the most sort of important pieces that I want to keep in my visual, so that I'm able to actually compress in a lot of different data variables. Another thing that that's important to think about in the visual design when you're creating information graphics is I think we could call clarity of purpose. So Edward Tufte says that good design is clear thinking made visible. And what I really mean by this is beyond sort of how clear, legible is my graphic, can I differentiate the different parts well. The sort of clarity in design is also about the clarity of message, the clarity of mission. Why am I even making this chart? Why am I sharing this chart? What is the point of this chart? And having a clear idea of that is important when you're making decisions about the visual design. So this is an example of a couple of charts exploring how music preferences have changed in 2 decades. So this is an imaginary data set, just to use as an example. And so in this imaginary data set, students from a university have been surveyed in 1994, and then students surveyed in 2014 and asked about their music preferences. And so we've got 2 pie charts which are showing the different proportions of the preferred music style of the students. And so we can see on the left that, for example, hard rock is 35% of the students, samba 25%, hip hop 20%. But if we look to 2014, although we can see, sort of the shape of the proportions of the different styles preferred, what you'll notice is with the 2014 pie, we've removed the page numbers, so you have to judge from just the visual. We can see sort of the rough shape, but the whole point of this graphic we see in the title is to show how music preferences have changed. We're interested in change. So if we look at the proportion of students who prefer hard rock, in 1994 to 2014, it looks like that proportion has been bigger. Hip hop, maybe that has gotten bigger as well. But if we look at samba, I'm not sure if that's 25% in 2014. It's not very easy to see, because a pie chart is best for showing parts of a whole. It's for showing proportions of a whole, and being able to compare between 2 pie charts. And if you remember when we were thinking about the different visual variables, that actually visual system comparing angles is actually quite difficult. I can't really tell if samba is any bigger or smaller. I don't know what the change has been. So if we were simply to redesign this data just in a completely different way, where we're really focusing now that we're interested in change, and so we could do this this different way of presenting the data, where we're using just a straight line to show the change from one year to the next. It's now much clearer, both sort of what the relative proportions are, what are their order in magnitude, but also what the change is. So the key thing here is to think about, what is it I'm interested in? What is it I'm trying to show? And actually picking your chart type to really serve purpose. This is other example is from it's actually from a scientific paper, which is all about bees. It's a paper which is a piece of research about bee-plant interaction. So which bee species forage in what plant species and which plants they pollinate. And so this research is, there was a study in 1880 about which bee species are related to which plants. And then scientists redid the study, I think in 2010, so that they could investigate the sort of change in the network of interaction. So do the same bees fly to the same plants? Do we observe the same plants at all? And so on. And so this is the graphic that was included in the paper. And you can see sort of the full thing and then a zoomed in thing. And it's just, there's so much information, so much going on here. It's sort of completely impossible to see what on earth is going on here. It's just far too much. And I think that this sort of cartoon sums up what's going on. It says, yeah, I'll pause for a moment so you can let this information sink in. Again, you know, simply by creating a visual of your data doesn't necessarily mean that, you know, you created something that is sort of insightful and helpful. It's just, yeah, far too busy to really tell what's going on. And so what we can compare this with is Maurice Stephaner, who's a visualization designer, was tasked with redesigning the graphic from the paper. And it should be clear that the first graphic was included in a scientific paper. Stephaner's graphic was for Scientific American magazines. It is for a different audience. This is for a interested public rather than researchers. But still, Maurice Stephaner was sort of tasked with redesigning this graphic so that it would be sort of clearer, so that it would be digestible. And what he did is he assessed that there's just simply too much information going on in that network, and it would be, if we were sort of centered on the network, it would just be impossible to redesign that in a way that is clear, that the patterns that we can sort of pick information, pick insights out of. So really, in order to make something that's digestible and consumable, he would recenter the graphic on the bees rather than looking at the whole work. So in this graphic, what he's done is each of the circles is an individual bee species, and then the kind of bars that you see radially around the circle are representing different plants. So the encounters of that bee with the different plants, and he's encoded whether the bee plant interactions have changed between the two timestamps with color. So we're seeing if the bees were not observed going to that plant, whether they, you know, were observed going to the same plant, or whether there are new plants that they were going to. And so by centering on the bees, what we can do now is we can see if there are bee species which have similar patterns in this kind of around the circle. We can see, are there species which are behaving similarly, or that there are similar changes in their behavior between the two timestamps of these studies. And it's, yeah, it is something that's much easier to get a grip on making comparisons and sort of overviewing things in this graphic. The other thing that Maurice Stephaner did in his redesign is that he chose to really emphasize something that was very important in the research paper, but which had been kind of completely lost in that network diagram, which is actually many of the bees had disappeared. They'd gone locally extinct, weren't observed in the second study. But that was just kind of drowned out in the network diagram. And so what he's done instead, he showed them those bees that went locally extinct. Those were the kind of hatching And so actually the takeaway message of this visual is that actually a lot of the bee species are missing. And so that really is a very different takeaway between the two ways of presenting this information. So this is really a sort of a strategy of if you know you're dealing with a very complex, very large data set, by kind of refocusing on what part of the data wants to be the kind of the center of your graphic, can be a way of sort of taming complexity and making something that that is legible, that is digestible. So a sort of another example of this, really thinking about, what is the visualization, what's the sort of the main message of my visualization. You can think back to from last week, I was talking about uncertainty in cultural heritage data. That's something that's really common. Often often there is uncertainty in our variables. So in a particular, a very common instance of this is in dates. In a lot of my PhD work, it was dealing with museum collection data where we don't have exact dates for many items in the museum. And so they would be recorded as, circa this date, or, within this decade or within this century, but we don't have an exact year. That's pretty common. And so in Dive into Color, which I talked about last time, this was a visualization project with the Smithsonian Design Museum. And it was visualizing their collection by different colors and different color combinations. It was all about looking at fashions for color over time, looking at advances in color technology and pigments and dyes, and how we see that in the collection, the different items over time. But in this collection, as I said, a lot of the dates were very uncertain. But that was not sort of the main story, the main sort of central thing that we wanted to focus on in this data. What I did in this design is that each of the items is represented as a thumbnail. And so the area covered by a data point is actually, is the area of the thumbnail. It's not just one small point. And the way that the data is arranged, it's arranged in this kind of collage layout. So although I don't have sort of big error bars on this, where it's designed, it's not encouraging the viewer to try and read off exact dates. It's not, I think it doesn't encourage you to do that. And so this is a way that I've designed this visualization so that it's all about color. It's all about being able to see trends in color over time. And we thought about uncertainty and a way of presenting the data with that in mind, but it's not the sort of main central point of this graphic. So it's really worth thinking about what is the kind of the main point, the main thing that I want to be communicating, that I want to be looking at when I'm visualizing data. So as I said earlier, design is not a science. It's not a question of, it's often not a question of there being one correct answer. There can be a whole array of different approaches that have their own, strengths and weaknesses. But I think there are kind of a set of questions that it's very useful to bear in mind and to be asking yourself when you're creating visualizations. Do I think this is clear? Could it be clearer? How could I help my audience? Really think about what are the most important elements of this visualization. Are there elements here that I don't need here that I could remove? Are there elements that really I should be emphasizing more, that are more important than they look in my current design? Are there elements that I want to keep that should be here, but I want to draw less attention to, that aren't kind of the main thing? And really to always bear in mind, what is this visualization for? What do I want my audience to see? What do I want them to be able to do with it? What do I want to convince my audience of? does my current design achieve this? And then if you think that it doesn't, you know, what could I change that would bring me closer to that? It can be really difficult, especially when you're dealing with complex data with lots of variables, especially if it's you know, a really large data set. It can be really difficult to achieve something that is really, really clear. And it is often a case of kind of balancing trade-offs and seeking compromises between different requirements. And the way to sort of go about that, I'd strongly recommend, is always just try things out, try out changes. You often only know if a certain change is going to be an improvement or not by just trying to see what it looks like, and yes, and then you'll know. Always, yeah, just be trying things out and seeing what it looks like, and seeing if, yeah, if this idea you've had might be an improvement, might solve this problem, can make your visualization more legible, that it's sort of better designed for the purpose that you have in mind. So now I'm going to talk about visual design for communication work. So this is really thinking about what is the sort of the tone, the associations, the context, the sort of the cultural context that you create and that you refer to when you design a visualization. And this is sort of partly about what happens on the sort of the subconscious level on the graphical side of things. So as an example, this is a visualization of a sort of an evolutionary tree of sorts. But you can say this information in different ways. So this graphic here, it's very readable, it's very effective, but also it's creating certain kinds of image associations. For me, this looks very scientific. It looks very kind of researchy. This could be in a research paper, but we could present, you know, roughly the same data like this. And this really looks very, very different, very, very different feel to it. It feels like, you know, you might find this somewhere else. I don't think you'd find this in a research paper. It has a very different emotional effect. And in communications, the emotional effect can matter a lot. And I think even in research, subconsciously, this can matter a lot. If you think you're working on a problem that looks a certain way, I think that does affect how you think about that problem. And you can see this is, yeah, really sort of look like two very, very dissimilar things. This is another example. So both of these graphics are showing the sort of tracking data of a bird over a period of time. So the one on the left is an eagle that was tracked for 20 years. And where did it go? And then on the one on the right is tracking a series of albatrosses circling Antarctica. If you have a look at these two graphics, which of these two do you think went viral on Reddit? Well, I can tell you that it is the one on the left which went viral on Reddit. So yeah, Reddit is where sort of, pieces of the internet are shared and can be upvoted, which sort of demonstrates a sort of big popularity of some graphic or some link being shared and being very sort of immediately viscerally of interest. So it was the graphic on the left which went viral on Reddit. And the one on the right was actually, it comes from a book that was created by James Cheshire, who is a geographer and cartographer at UCL. And he collaborates with a graphic designer, and he created this book, I think, called Where the Animals Go. And the whole book is visualizing these tracking patterns of animals which have had sensors. sort of attached to them, and so we can see where the animals go. And so it's a book full of these sort of beautifully designed maps. And James Cheshire was saying that he felt a bit miffed that he saw that this eagle map had gone viral on Reddit. And he said, it's really basic. It's sort of Google Maps, and my whole beautiful book that we've done on this topic has not, gone viral on Reddit at all. And he said that sort of after feeling a bit initially miffed, he sort of calmed down and felt, well, actually, I'm sort of comparing apples and oranges. This graphic sort of was, attracted a lot of interest, but it was, something that people, will just have had a look at and have moved on to, something else with the rest of the day. Whereas I've created this, book with actually a lot of detail, a lot of sort of annotations, a lot of information. It's just really an entirely different thing, not worth comparing. But what I think is quite interesting about this comparison is that as a kind of snap judgment, when you immediately see these images, for me, it's the one on the left, which immediately goes, that's like tracking data. It immediately, to me, I'm sort of getting the light bulb of that's Google Maps, and that is something that's been tracked over time. And when you see it's an eagle, I think that's immediately sort of, oh, wow, that's, this is a real path that a real eagle has taken over the 20 years. Whereas the albatrosses example on the right, I think I might almost say that it's so kind of perfected and designed that it almost, I sort of have lost that immediate kind of visceral reaction of that's a real thing, a real tracked thing. It almost looks kind of, the graphics look a bit too perfect. So I think that it's quite interesting that there are these kind of gut reactions that factor in with visual communications and really do have an effect in how we sort of read and perceive and understand visuals that we come across. So why does any of this matter for visualizing cultural collections? Why is this important? And I would say that it's not always highly important. If you're making quite sort of standard types of graphics, line charts, bar charts, and you're really, interested in just understanding the shape of your collection, thinking about the sort of, these visual design, the sort of the tone of the visual design is going to be less important, and certainly thinking about legibility and which chart type you've chosen is going to be more important for you. But that doesn't mean that there aren't cases when visual design is important with cultural heritage data. I think an example of this is a project from Edinburgh University. This is the Witches database, where they're mapping the places of residence of accused witches. I think this is from the it's from the 17th century. It possibly spans a time period longer than that. But I think a really nice touch here is that rather than sort of the normal thing to do would be you putting dots on maps. We all put dots on maps, but instead of that, they have used these little illustrations of people. And I think it's a wonderful reminder that when we're working with data always represents something. Sometimes those things are people, and I think this is just a really effective way of reminding people what exactly they're looking at. It's a data map, but really we're looking at the places of residence of people. So I think it's a really excellent piece of design. Another thing to think about, if you remember last week, we talked a bit about generous interfaces. These are when we can use data visualization as a way to help the public or interested individuals in exploring and getting a better sense of our collection. So these are ways of presenting collections that are not so much geared to research or scholars who tend to have a clear idea of what they want from a collection. This is much more about presenting collections for people who don't necessarily know what they want to see, who don't necessarily know what's in the collection. And we can create visualizations which help to show the kinds of things, the shape of the collection, the different kinds of variables in our data. And this is really about presenting collections in a way that is really welcoming and enticing and visually interesting. And so for these kinds of interfaces, thinking about, you know, the tone, the context, the visual design is important. We want something that is attractive, that is engaging. That's sort of, you know, the half of the point of these. Similarly with the Manly Images website, this is a, you know, it's a type of chart, it's a tree map, where we're showing proportions by the area of these rectangles, but it doesn't look like a chart. It looks, you know, sort of, it looks like an interesting interface, but it doesn't look scientific. It's very welcoming. It's you know, sort of, it's showing, it's revealing all of this content in the collection. And I think striking, yes, thinking about the tone that you strike is important. It is going to change how people feel when they you know, come to your site, come to your visualization. And even in research, aesthetics can be important when we're presenting cultural heritage data. This is a recent paper called When the Tech Kids Are Running Too Fast, Data Visualization Through the Lens of Art History Research. And essentially the paper is looking at why has there been sort of relatively quite limited take up of data visualization in art history compared to other humanities disciplines in the digital humanities. And there are sort of a range of possible, well, a range of reasons given in the paper, but one of those is about aesthetics. And the authors found that aesthetic experience is critical for an audience of art history experts. And attracting more interest in the art history community is going to mean putting aside the aesthetic standards used in the software world to propose visualizations users will be satisfied to engage with. And so they're essentially saying that a lot of the visualizations that art historians have been seeing sort of in the digital humanities world are aesthetically things that they don't feel are kind of to do with them, or that they feel that they don't want to be involved with. You know, these things that I'm seeing, they're not for me. That's something that I'm not interested in. And so aesthetics, yeah, can be really important in really sort of in setting where readers feel that these visuals belong. Who are they for? What are they for? And I think it's something that has been sort of not a sort of not a main focus, and it's been overlooked for a long time. But aesthetics, it can be important even in research. This is two different visualizations that actually both show the same thing. So it's two separate designers created visualizations of its place names in Germany, and it's looking for patterns in the endings of place names and seeing, are there sort of geographical distributions of certain endings of place names? Do we find that these endings are all, you know, in a certain part of Germany, or are they everywhere? What are the kind of the shapes that we're seeing? And so there's this visualization sort of in the yellow, and then a very different looking visualization here, sort of multicolored on black. I think they're both you know, good designs. They each have their own merits, but where do you think each one belongs? Who are they for? How does the choice of color and how the visualization works affect sort of your impression? I think for me, comparing these two different designs, I feel like the first one, the yellow one, looks much more kind of editorial in a newspaper, is the kind of impression that I get from that. Whereas the second one, because it's on kind of dark mode background, looks a lot more sort of techie, as the kind of feeling that I get from that. But it's interesting. It's the same data. It's the same visualization essentially, but they've just like a very different feeling from both the visual design and the kinds of things that you can do in the interaction as well. So that was, very, very quick. Don't worry if you've just had a chance to sort of glance at these. We're going to move on just so that we have time to talk about tools, which is the final and important thing to think about with visualization. So what tool do you want to use when you're visualizing data? And the sort of the presentation really today has been really very tool agnostic, and that is deliberate because people do use lots of different kinds of tools. And when I'm asked, what is the best visualization tool, there really is no best visualization tool. There are a whole lot of choices, and it really depends on your circumstances, both what it is you're comfortable using, but also, what it is that you want to make, what it is you want to create. So these are sort of few things to think about when you're choosing a visualization tool. Do you want to use an app, or are you more comfortable using a programming language? Do you already know, which programming language you already work in that you want to continue working in? You have to think about, where am I going to do data processing? So as we said at the beginning of this presentation, data visualization involves a lot of data processing. It's not just sort of working with visuals. So do I want an app where I can do that also in the same app, or maybe I want to use different apps? I'll do my data processing somewhere else. Is this a quick chart? How long do I have to spend making this? Do I have more time? What sort of level of customization or flexibility do I want with the design? Do I want to create just something very standard, something very quick, or do I actually want to have a high level of flexibility? And do I want something that's interactive or something that's static? Again, this is an important consideration. And I think I can roughly sort of sketch out the shape of the sort of selection of different data visualization tools. And this really is a selection of the options out there. There is a whole lot of tools out there, and I've missed off that if you, for example, you're doing network visualization, then Gephi is a specialist tool for that. If you're doing map making, there are specialist tools for that, like QGIS. So here I've just sort of concentrated on more sort of standard charts and graphs. And think about, either there are sort of the app side or the programming side. On the app side, there are spreadsheet tools. You can make charts and graphs in Excel. Using pivot tables, you can do your sort of data summarizing, you can create those aggregate tables and you can make charts. It's not, hugely flexible, but if you want a standard chart, there's, no point over engineering for the sake of it. You can do things in Excel and Google Sheets. There are business intelligence apps, or sort of BI apps like Power BI, which is the Microsoft one, or Tableau, they're really sort of data visualization tools, which are, as it says, set up for business intelligence. So it's really sort of making dashboards for companies, but actually these are very powerful in terms of creating different kinds of visuals. And also you can do your data processing in the tool as well. So I know that at the British Library, we have a license for Power BI. So this partly depends, does your institution have a license for one of these? But actually, I've seen some really visually sophisticated things made in Tableau. So this isn't a kind of it's not necessarily, limiting if you don't want to use a programming tool. You can make some amazing things in Tableau. And then the next class of things are the web-based apps. And these ones I found are typically kind of aimed at journalists. And two of these, Data Wrapper and Raw Graphs, are ones we're going to try out today with British Library data. Flourish is another one, which is very good for creating interactive visualizations on the web, but you have to create an account, and if you want to use the sort of free tier, you have to publish any graphics that you make, and you may not want to do that. You may want to keep them private, but it is otherwise a very good tool. On the sort of the programming languages, it really depends, what programming languages do you know, or are you sort of interested in learning? And I think that we can sort of characterize the different code libraries in terms of whether they're low level or high level, by which I mean low level means very high degree of control in creating your graphics, but you're writing a lot more code and it's taking longer. Whereas the high level ones is they've abstracted a lot more of the process. So it's much quicker, you write less code, you have less control. So again, it really depends what it is you want to make. So Python, Matplotlib is a sort of classic example of a very low-level library, and then there are a selection of different high-level libraries like Bokeh, Seaborn, Plotly, Altair. Some of these you can support interactivity as well, which is great if you're publishing things on the web. R, I don't work in R, but I know that R really there are sort of an amazing universe of visualization sort of library options in R, and it's very, very good for data processing. So I don't use R, but I've seen a lot of amazing things made in R. And then the last one here is JavaScript. I'd say that Python and R are much better for data processing, and so often I will do my data processing in Python, but then I'll create a visualization in JavaScript, because JavaScript is the scripting language of the web. It really, if you want a very high degree of control and being able to customize visualizations for the web, then doing it in JavaScript is your best bet there. D3 is the sort of low-level JavaScript visualization library where you have really sort of a whole universe of options and how you want to visually present your data and design your visualization, but you're writing a lot of code. But there are also sort of more abstracted libraries like Vega and Vega Lite, which are good for making quicker standard graphics. But yeah, the very best way is to learn is to learn through making. So I definitely say, if you're interested in getting better at making visualizations, learning how to do this, you should just definitely dive in and have a go, because yeah, the best way to learn is to make these, and you learn so much along the way.